Alright guys, today we're going to try to tackle section 2.6. The first video we're going to work through examples 1 through 3. In the second video we're working through example 4. We're going through proofs, so it's not going to be easy. I need you to slow down and take as good as notes as you can. First of all, a proof. A proof is a logical argument that shows a statement is true. A two-column proof, it has numbered statements and corresponding reasons that show an argument in a logical order. Alright, writing a two-column proof for this situation in example 4. We did this example before from lesson 2.5. We have given the measure of angle 1. The measure of angle 1 is equal to the measure of angle 3. That is given. And we're trying to prove the measure of angle EBA is equal to the measure of angle DBC. Okay, let's try to work through the steps. First, we know that the measure of angle EBA is equal to the measure of angle 3 plus the measure of angle 2, and that is the angle addition postulate we learned last chapter. Okay, since we know that the measure of angle 3 is the measure of angle 1 is equal to the measure of angle 3, I can replace the measure of angle 3 with 1. So instead of the measure of angle 3, I'm going to put the measure of angle 1 because of substitution. I'm just substituting it because they're equal. And I can also say the measure of angle DBC is equal to the measure of angle 1 plus the measure of angle 2 because of the angle addition postulate. Okay, now if you look, you see that measure of angle 1 plus measure of angle 2, measure of angle 1 plus measure of angle 2, those are equal. So using the transitive property of equality, I can say that because the measure of angle EBA is the measure of angle 1 plus the measure of angle 2, the measure of angle DBC is the measure of angle 1 plus measure of angle 2, I can legally say that the measure of angle EBA is equal to the measure of angle DBC because of the transitive property of equality. And there, folks, is your first proof. Good job. Alright, you try. We have 4 steps of a proof. Okay, give the reason for the last 2 steps. So given is AC is equal to AB plus AB. We want to prove that AB is equal to BC. Okay, so again, you always write down your first step first, and it's given. Next, we're saying that AB plus BC equals AC, and that's your segment addition postulate. Try to figure out the reasons for these last 2 steps and push pause. There we go. I know that, let's go through this. AC equals AB plus AB. AB plus BC equals AC. So transitive, we know these 2 things are the same, so I can say AB plus AB equals AB plus BC. Okay, it's the transitive property of equality. Then I can subtract AB from both sides, and I'm left with AB equals BC. Alright, what's a theorem? A theorem is a statement that can be proven. Once you have proven a theorem, you can use the theorem as a reason in other proofs. Yes, very exciting. So let's go through some theorems. Theorem 2.1, the congruence of segments. Segment congruence is reflexive, symmetric, and transitive. Let's get some examples here. I have reflexive. Okay, for any segment AB, we know that segment AB is congruent to segment AB. That's sort of a duh. If I'm looking in the mirror, I know that I am congruent to myself. Okay, reflexive. It's a reflection. So for any segment AB is congruent to segment AB. If you are reflecting yourself in the mirror, you are equal to you. Symmetric. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Symmetrical. Doesn't matter what order, they are symmetrical. And transitive. Like I said, for some reason, thinking about trains keeps transitive in my head. Maybe you can think of something else that'll keep it in your head if that doesn't make sense. So, if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Congruence of angles. Angle congruence is reflexive, symmetric, and transitive. And amazingly enough, the explanations are very similar. So for any angle A, angle A is congruent to angle A. Okay, reflexive. It's a reflection. For any, student named Joe, he looks in the mirror, Joe is congruent to Joe. It's a reflection. All right. If angle A is congruent to angle B, then angle B is congruent to angle A. It's symmetrical. And transitive. If angle A is congruent to angle B and angle B is congruent to angle C, then by golly, angle A is congruent to angle C. Ta-da! Alright, example 2, name the property shown. If angle R is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. That is that transitive. Let's try to write that a little neater, sorry. Transitive property of angle congruence. Transitive property of angle congruence. B. If segment NK is congruent to segment BD, then segment BD is congruent to segment NK. That is the symmetric, sorry about that. Property of segment congruence. That says symmetric property of segment congruence. You try. Name the property illustrated by the statement. Push pause. I'm going to do both 2 and 3, and then you can push play again. Okay, I have the reflexive property of segment congruence for number 2 and the symmetric property of congruence for number 3. Example 3. Using properties of equality. Prove this property of midpoints. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM and AM is 1/2 of AB. So we have a given. M is the midpoint of AB. And we're proving 2 things. AB is equal to 2 times AM, and AM is equal to 1/2 AB. Okay, get all that written down and then turn the page, or keep playing because I need to write it all on the next slide. Statement and reasons. Okay, my first statement is M is the midpoint of segment AB. And as usual, that is given. Okay, so if M is the midpoint of AB, we know that, I'm just going to draw it right here, A, B, M. Okay, we know that segment AM is congruent to segment MB. And that is because we know the definition of, that's of midpoint. All right, what else do we know? Okay, if we know that segment AM is congruent to segment MB, we know that the length AM, because remember, segments or pictures can be congruent, but lengths are equal. Something we have to keep on reminding ourselves because it's easy to forget. So we know this is the definition of congruent segments. Sounds like something that I'd put on a note card to try to help me remember. All right, what else do we know about segments? Well, we do know a segment addition postulate. So I know that AB is congruent to AM, is equal to AM plus MB. Okay, AB is equal to AM plus MB because of our segment addition postulate. Okay, I think I can use some substitution here too. Let's see. If we know that AB is equal to AM plus MB, we know that AM is equal to MB, I can say that AB is equal to AM plus AM, because right here I have AM is equal to MB. So I take this MB and I make it an AM because of substitution. Cool. Now I know that AB is equal to 2 AM. Okay, that's just simplifying. The book calls it distribution. I would accept either one. Distribution. All right. Oh, there's a typo. Sorry. Catch that. Okay, and we also know that 1/2 AB is equal to AM, and that is our division property of equality. All right, we proved, get a different color here, sorry. We proved our first thing and our second thing. There was an A and a B. All right, and I know it's hard, but you guys just have to keep on practicing, okay? You try. What if? Look back at example 3. What would be different if you were proving that AB equals 2 MB and MB equals 1/2 AB instead? So what we proved was 2AM equals AB. I'm going to write that a different way though, so it matches what we've been doing. Okay, what we just proved was AB equals 2AM and AM equals 1/2 AB. Because this is what our picture looked like. A, B, M. What if we were proving that AB equals 2 times MB and MB equals 1/2 AB? Okay, what would we change? All right, go ahead and push pause, and I'm going to write out a little answer. Okay, all we would have done in the previous example was where we made the statement AB equals AM plus AM because of substitution, we would have said AB equals MB plus MB. We would have substituted the other segment length in and then just continued on. So look at that and make sure it makes sense. If not, ask a question tomorrow. All right, look this over, copy this down. I'm going to talk through it. Proofs can be the most difficult part of geometry. Writing all of the postulates and theorems on index cards will help. When you see a new problem, you can try to arrange some of the index cards as a method of completing the proof. We're going to try this in class, maybe to help study for the quiz or the test at the end of the chapter. But let's talk through this. Writing a two-column proof. In a proof, you make one statement at a time until you reach the conclusion. Because you make statements based on facts, you are using deductive reasoning. Usually, the first statement and reason pair you write is given information. Okay? Example, prove the symmetric property of angle congruence. Given, angle 1 is congruent to angle 2. Prove angle 2 is congruent to angle 1. Okay? Copy or draw the diagrams and label given information to help develop proofs. Okay, the first thing's in red. Angle 1 is congruent to angle 2, and that's always given. The measure of angle 1 is equal to the measure of angle 2, and that's the definition of congruent angles. Okay, I can say the measure of angle 2 is equal to the measure of angle 1, and that's what we just learned, the symmetric property of equality. So we know that angle 2 is congruent to angle 1, the definition of congruent angles. Remember, these are measurements are equal, drawings are congruent. Okay, our number of statements is going to vary. Okay, the person sitting next to you may have 5 steps to do this, where you have 3, and we need to give a reason for everything. The statements based on facts that you know, or conclusions from deductive reasoning. Definitions, postulates, or proven theorems that allow you to state the corresponding statements. This is how you do a two-column proof. Break time. Okay, we'll do the second part later. Good job.